The next section is on exponential functions, and so we'll be looking at how to solve for different exponents. So we know that b raised to the x is equal to b raised to the y, then x is going to be equal to y. So the main thing here is we always want to get our bases equal to the same value. So we'll look at a simple example problem just to illustrate this definition here. So we have 5 raised to the 3x power, which is going to be equal to 5 raised to the 7x minus 2. So the first step in solving this example problem is determining if the base is the same. The base is the same for our example problem, so we don't have to do anything to manipulate that. So we can go ahead and move on to the next step. So the next step is we can apply our formula where we know that x is going to be equal to y, or 3x is going to be equal to 7x minus 2. And so we can go ahead and solve that. And this is a really easy example, and we get x is equal to 1/2 for our solution. The next example problem is a little bit more challenging, where our bases are not the same, but it's very easy, or it's very obvious what we need to do with this 9. So what we're going to do is, the first step is we want to determine if the bases are the same, and if they're not, then we want to go ahead and do some algebra manipulation in order to make sure that the bases are the same. So you can see here, this is what we're doing. We're taking this 9 and making a 3 squared out of it. And so now we have the same base, 3 raised to the z, which is going to be equal to 3 raised to the 2 multiplied by z plus 5. And so now, because the bases are the same, we can go ahead and solve for the exponent. So z is going to be equal to 2 multiplied by z plus 5. That's what we have here. And so we can go ahead and solve for z, and we're going to get z is equal to -10. So pretty much, in order to solve these example problems, all we're trying to do is make sure that the bases are the same value, and then we can solve the exponent for the variable that we're trying to determine.